Greetings, I'm Yvonne Stapp for Science for the Public, and I welcome you to our Contemporary Science Issues and Innovations program. The last 2 years marked a global heat record, the hottest 2 years since global temperature has been recorded, and climate experts are very concerned. Today, we talk with two distinguished scientists about the acceleration of global heating and how it must be addressed. Dr. Mathew Barlow is professor of climate science at the University of Massachusetts Lowell and a specialist in droughts and floods and heat waves associated with climate change. Dr. Jeffrey Basara is a professor of meteorology and also the chair of the Department of Environmental, Earth, and Atmospheric Sciences at the University of Massachusetts Lowell. He specializes in complex integrated processes across the weather and climate and ecosystems, especially associated with extreme rain. We certainly appreciate their willingness to explain the global heat spikes and their impact and what has to be done to mitigate the damage. Dr. Barlow and Dr. Basara, welcome and thank you very much for joining us today.
So thanks very much for having us and for covering this topic.
I'd like to start by referring to an article you wrote in The Conversation this past summer about the climate issue, and you mentioned there that we're on track to cross the 30-year average threshold of 1.5 Celsius within 10 years. And I know that there's a lot of concern within the climate scientists community. So the first question there then is, what is causing this acceleration, this spike in heat?
So the 1.5 degrees Celsius target was set at the Paris Agreement, was set as a goal for the international community to try to not get over that 1.5 degrees. And that 1.5 degrees is averaged over a 30-year period so that, naturally occurring year-to-year variability doesn't sort of count towards it. And right now we're on track to sort of blow past that threshold within, say, 10 to 15 years with current policies. And that threshold was picked to try to be an achievable goal, but one that limited the impacts of climate change as much as possible. So it's certainly very concerning that we are on target to go over that goal, to exceed that goal. And then one thing that has been concerning both, I think, everyday folks as well as climate scientists is the last couple of years have been so exceptionally warm.
Yes.
So it looks like climate change is accelerating, that the warming is accelerating. And I think that there's very good agreement that the warming is accelerating, and a fair amount of that warming was expected to accelerate, and the climate models and the climate projections took that into account. So that some of that acceleration is expected and predicted and projected. Where I think there's less agreement is whether we've moved beyond the amount of acceleration that was expected. And I don't think there's, I'll let Jeff weigh in a second. I don't think there's good agreement on that yet, but there certainly have been some concerning analysis, scientific studies that have highlighted some evidence, at least, that things are progressing faster than expected, and that of course is very concerning. Jeff?
Yeah,
Right.
I couldn't agree more. First of all, thank you for having us. Really appreciate the opportunity to visit and to share some thoughts on this very important topic. And I couldn't agree more with my colleague, Dr. Barlow, on all accounts. We did expect, as the scientific community, to see some level of acceleration. But I think what is also surprising is that maybe this is more than we had anticipated. Right. And when we think about numerical weather and climate models, when we see extremes in the model, sometimes as scientists, it's difficult for us to grasp whether that's the real endpoint or maybe somewhere in the middle when we look at an ensemble of predictions. And what's happening and what seems to be happening even at this point is kind of on the upper threshold
Right.
of what we anticipated from numerical simulations, from modeling the future climate, from our scientific understanding. And I think that is, to the scientific community, a little bit perplexing.
Yes.
Because we would have maybe expected to see it somewhere more in the middle of the range.
Yeah,
And right now it's running a little bit at the top of the range.
Right. The extent of this, the spike itself, was probably not expected, like as you say. So what caused it?
Well, I'll take a quick stab at it in the sense that, it's probably too soon to know for sure. The Earth system in general is a system that's made up of lots of what we call feedback mechanisms,
right.
that are both positive and negative. So sometimes processes may work together to enhance a certain type of feature. Sometimes they work against each other. For example, we know that carbon dioxide and greenhouse gas emissions have an impact on the radiation budget of the planet, which has an impact on heat in the sense that it traps
Right.
more heat. We would expect temperatures to rise. At the same time, aerosols in the atmosphere have a negative effect. They actually oppose that because they block downwelling solar radiation from making it to the surface and actually decrease the amount of net radiation that's in the system. So we have these positive and negative feedbacks that are always sort of either enhancing or working against each other. And sometimes it's really difficult at this point in time to figure out, which one of these specific features might be responsible for a particular trend or a particular set of dynamics that are unexpected, like we're seeing in this case. So I think that the overall jury is still out on what the cause is. But a couple of things that have happened in more recent years that are known is that we generally are seeing either the same or less aerosols, especially in certain locations. We know the oceans are warming at a pretty fast rate. It's not just the atmosphere, it's the oceans themselves. That may be having a feedback process, especially when we look at certain areas of the planet. We also know that, and as expected, the tropics are not warming as much as the poles are warming.
Yeah.
And some of those increased rates may be regional, and then averaged over a global area sort of show up. So there are a number of different factors that are going on. I think the jury is still out on some of those.
Okay. Dr. Barlow, any comment there?
Yeah, I agree entirely. One way to think about the big picture is that we've had at least two major influences on the climate, human-caused influences on the climate over the last 100 years. One is emitting greenhouse gases from fossil fuel burning, but the other is also emitting particulate pollution from burning. And we've been much more successful at reducing that kind of pollution, the aerosol pollution, the particulate pollution, which is important because that's a huge, absolutely huge health impact. So it's important to reduce that. But they were kind of offsetting factors. So the greenhouse gases were causing warming, and the particulate pollution, which reflects sunlight, causes cooling. So we've taken away one of the offsetting factors without limiting the other. And that certainly, I think there's little question, that's a big piece of what we're seeing.
Okay.
As Jeff was saying. And then the question is, are there other things that we don't understand as well that might also be going on, which is particularly troubling because the situation is difficult enough as it is. The other thing I think I would throw out as sort of a piece of context is that what we've seen, for instance, this summer in the Northeast, very hot, exceptionally dry, wildfires, smoke.
Yes.
That was already expected. That's already what we expected to happen. But I think it's hard to appreciate, even as scientists, what even a modest amount of warming looks like. So we haven't reached 1.5 degrees yet. We're only at maybe 1.2 degrees Celsius. But that's a number that just seems small and that you probably wouldn't notice temperature-wise if you went into a room. But that's the globally average temperature. And I think it's very hard for everyone, again, including scientists, to contextualize what those impacts are going to look like as they play out. And that's why the 1.5 degree target is such an emphasis, because we've already seen, very large impacts, not even meeting that level. One thing that I hang on to as a piece of context is that 20,000 years ago, at the peak of the last ice age, where we are right now, the Boston area would have been under a mile or so of ice. That was only 5.5 degrees colder globally. So when you're talking about a degree of change, that's globally average. That's a vast change, and it's just hard, I think, to keep that context in mind.
That's true. For one of you, if you could just very quickly clarify this aerosol problem. We're seeing more about that from shipping primarily, and that that has affected climate very significantly. And you think, ships, come on, they fixed that one problem and it seemed to cause another. Could somebody clarify for that, just the aerosol issue for us, so we know what that is?
Jeff, you want to take that?
Sure. And aerosols have been a key issue in the U.S. and around the world, and still is. And it's one of those interesting things. And before I talk about shipping specifically, it's also really important, as Matt pointed out. The Clean Air Act and the laws that in this country alone addressed the fact that we were seeing many different types of pollution and needed to clean up what was being emitted by humans to the atmosphere. And we know that since that point, we have cleaned up the atmosphere, so to speak, here, especially in North America. But we see some of that, a lot of that happening worldwide, Europe, other locations. And one of the consequences of that is by cleaning up the atmosphere in that regard of what we were emitting. And we're talking about particulates, smoke particulates, but we also are talking about other types of gases that are emitted as well, what we call, NOxes and SOxes, sulfur dioxide, nitrous oxide, those types of gases that are also emitted to the atmosphere that can form different types of volatile organic compounds and have impacts on ozone, things like that. We did a great job in this country of cleaning that up, and we've seen a significant reduction in those types of aerosols. Now, there are other types of forms. Shipping is another one. We see more shipping across the oceans of the world. We know that supply chains matter, right? And different types of, fuel efficiencies with different types of shipping do matter in terms of what actually is emitted. And the more, global shipping that we see using older technology types or older types of surface fleet type carrying combustible engines, so to speak, that's going to have an emissions issue back to the atmosphere in a wide variety of ways. And so, it's one of those real challenges that we face from a human side is when we do make efforts sometimes to clean up, we see other problems emerge.
Right.
Another example of that is also like the ozone layer, right? We know CFCs had an impact on stratospheric ozone. We've cleaned that up. We can have an impact. We can have a positive impact.
Right.
But sometimes our positive impacts just reveal other problems that still exist.
Right. And all of that underscores that this is a very complex system with a lot of integrated factors. It's really difficult. So modeling this stuff must be quite a challenge in any case. I'd like to ask for each of you to respond to this, if you would, to the implications now for the future. One of the things that might be important is that a lot of this is not reversible. When we cross some of these lines, we can't undo it, and that's a concern, I think. So I wanted to get that verified, if possible, from you two. And also, what are the implications for agriculture, for being able to live on the planet in certain places? All of that you have mentioned, flooding, everything. Could you each give some insight there?
Yeah, that's a big topic. So I mean, I think we're already starting to see the implications play out even in the Northeast, which has seen less impacts than many other parts of the world. So it's getting hotter. The seasons are changing. The warm season is getting longer. The cold season is getting shorter. We're getting more, somewhat paradoxically, more drought and more flood at the same time. So here in the Northeast, the annual average amount of precipitation is going up. But within that, we're getting more heavy rainfall and more drought.
Yeah.
So this year we've whiplashed back and forth between record wet months and record dry months. We're actually, I think last year is going to turn out to be turn out to be fairly close to average for much of the Northeast, even with all that back and forth. So a lot more whipsawing weather. And that is hard on agriculture, especially. People are growing things that have adapted to the historical climate, not a changing climate. So there are big agricultural impacts, which I think are already being felt in a lot of areas. It's also very hard on infrastructure. There's an increased freeze-thaw cycle. High temperatures are very hard on a lot of things. So there are a lot of very dire consequences. But I also would like to highlight that a lot of the solutions to global warming, to reducing fossil fuel, can also improve a lot of things. So if you focus on, say, reducing fossil fuel emissions in your house by getting a heat pump or participating in mass save and getting a higher efficiency heating system or just a better insulation, that will help global warming and it will save money. If there's more public transportation, if there's more affordable high density housing, those have a lot of positive impacts in addition to helping fossil fuel emissions. So I don't want to give people the sense that everything is doom and gloom and that we can't do anything and that everything we do will be hard. There's a lot that we're already doing. There's a lot that we can do, and it can help fix a lot of other problems, including making our air and water cleaner.
Okay.
So I'll leave it there.
And Dr. Basara, do you have anything to say about the implications? What areas, things like agriculture, warming seas, all of that, what does it affect?
Yeah, and so when I even teach my class and teach my classes, we know that, and we can look at the climatological record now, and basically just about everywhere temperature is increasing.
Yes.
That's a known, right? And it's warm season and it's cold season. But when we look at something else that's really critically important that is a major other contributor to climate, which is precipitation, we don't see the same type of thing. We don't see everywhere it's going up. We see some places where it's increasing. We see some places where it's decreasing. We see some places where it's becoming more variable. And I think there's a real important point. We talk also a lot about the temperature, and rightfully so. Increased temperature and temperature extremes do have direct impacts. But it also has a tertiary impact on the precipitation. And the distribution and redistribution of water will likely have the greatest set of impacts in the human system and the ecosystems moving forward. Because we know that human systems can't really do well without water.
Right.
Right? We might be able to mitigate the heat issue through different types of technology, but the water, once it's, if there are places that go into extreme water scarcity, we have seen globally that usually ends up leading to a lot of consequences, including conflict. And so when we look at the grand, the overall issue, when we think about agriculture, we expect that, increase in frequency and intensity of droughts globally. That's going to have an impact on agriculture, especially if we get those occurring in agricultural zones, which we expect.
Yes.
We also think about just water resources. In a place like the Northeast, maybe we won't have to deal with the overall magnitude of the water resources because precipitation is going up. When you look at places like California and the southwest portion of the U.S. and globally,
Yes.
we start to see that water scarcity is becoming a bigger and bigger issue, which affects every level of agriculture,
Right.
industry, and just overall basic, ecosystems and even recreation, right?
Yes,
So
right.
that issue of the distribution and redistribution of water is going to be as critical, if not more critical, than just the temperature impacts themselves.
Right. Thank you both for some very important points there. Much appreciated. Now then, in order to address this, and we need to do it quickly, and we've been at it for decades, what do we need to do? And I would like to focus especially on governmental and international policies, because it seems as though at an individual or very local level, we're a little more limited in addressing a very urgent thing. But in any case, would you both give your input about that, please?
Yeah, so that's I think the big question. I should first say that I don't know that we mentioned fisheries.
Yes,
and
yes,
as a
thank
coastal
you.
issue, sea level rise and
Right,
sea
right.
level acidification, as the ocean takes up more carbon dioxide, also becomes more acidic. So our coastal fisheries are
Yes, thank you.
changing. In terms of international policy, we probably we need to rethink our current approach. Right now there are annual negotiations, COPs, COP, Conference of the Parties. Those, I don't know that it's fully appreciated. Those actually have had some positive effect. So we actually are no longer on the worst trajectory for fossil fuel emissions. We're now sort of moved to the middle trajectory. So as dire as things may seem, they're not nearly as bad seeming as they were, say, 15 years ago. So there has been some progress on the international front, but we probably need to rethink how we do those meetings, because they're really heavily influenced by the fossil fuel industry, and recently have been led by members of the fossil fuel industry. So I think
countries that produce this stuff too.
Exactly.
On top of that, right?
Including the U.S., which is also a major
absolutely.
So I think we need to rethink that. I think actually there's also a lot we can do at the individual level, but maybe we can come back to that, and I'll let Jeff weigh in.
Okay.
At the internet
all right.
policy.
Well, I completely agree with that. It's interesting. The most recent COP, the COP was in Saudi Arabia. But interestingly enough, one of the biggest implications and impacts of that particular meeting was about addressing the issue of drought in places all around the world, because we are seeing an increase in drought and its impacts on water resources and agriculture. So there are discussions even occurring in these other meetings that are addressing some of these bigger issues that we are seeing rising to the table. With that rise in urgency, we will see hopefully increased levels of response. At the same time, we're always battling the fact that as the system that we have built, both in the U.S., the Northeast, and internationally, there is an increasing demand for things like energy and energy usage. And balancing that out is always a real challenge. And that's where I think we also need to look to the business world and to technology.
I see.
Everything needs to be more efficient.
Right.
And have policy, but also sometimes, we need to make our technology affordable. Having policy that drives that is helpful, but just mandating policy without allowing the technology to become an affordable, usable technology puts a massive strain on the system and often increases a little bit of backlash. But at the same time, we are seeing technologies in many, many sectors, including, and Massachusetts is helping to lead some of that.
Right.
And we're seeing technology advancements that I think are helpful and really are hopeful essentially mitigating some of these impacts into the future.
Right. The real issue, I mean, there's plenty of renewable energy resources at this point that are affordable and they're available. Some things are going to take up a huge amount of energy in the future. That has to be addressed, like AI and so on, I suppose. But what we need is an international policy to really address taking care of the situation across the globe. And so I just want to ask very quickly, because we don't have too much time left, that there isn't anything in the works that is international that says we're going to address this. What we get is words from these meetings. So do you think that we are nearing a policy?
I'm a little pessimistic on that, and because we're human beings. And we have a lot of differences in opinions. I would be hopeful that as the realization that we are trending in the wrong direction becomes increasingly aware and apparent, we would trend more towards trying to engage, and we have in the past. It's really important to think about the protocols that address essentially the ozone layer issue. That became an international issue, and we made changes. We can do it. We've proven it in the past. Why this one is more difficult is because what you're asking is as the world is becoming more advanced, trying to address a real important part of all the global economies. That is the energy issue, right? And it's the energy issue that's creating the problem, but it also has a potential for creating the solution. And there's so many disagreements there. So I am concerned that it's going to continue to be in this place of banter back and forth for what I would anticipate is too long to make meaningful addresses. But, I'm still hopeful.
Right. I understand.
I think the good, sorry, go ahead.
We just have a few minutes left, so make it quick if you could.
I was just going to say, I think the good news is that there's widespread political support across the world at the individual level. When you poll people, even in red states in the U.S., everywhere, people support strong movement on this issue. It's just been sort of bottlenecked at the top, and I think we have to acknowledge that a relatively small number of people are making a lot of money off this. But I think there is really widespread public support for this across the world. So I'm going to be optimistic about that.
Right. The issue is that there's plenty of public support. It is at the top level, as you say, the policy and also the resistance of the fossil fuel industry. And they're out there all the time sort of blocking things. And so the public is aware of this, but you can't do anything much about it. Very quickly, we only have a minute or so left. Could each of you give a quick synopsis of the work that you do?
So very briefly, we try to understand extreme weather, heat waves, also cold snaps like we've just seen in the U.S., and heavy precipitation and drought, try to understand how those extreme events are changing in a warming world at the local level. So that's the hard part, is trying to understand not just the big picture now, but how that might play out for individual towns and cities and farms.
Okay, thank you. And Dr. Basara?
Yeah, many of the same things, really looking at and for me particularly, looking at the changes in precipitation intensity, and specifically how drought is accelerating and intensifying at shorter time scales, how that impacts, and specifically how that impacts agriculture's and human systems. Because as we know, we need, there are a few things we need. We need shelter, but we need food and water too as a human system in order to have a sustainable human system. And those are major challenges.
Thank you, because these are very big contributions, and I hope you will stick with it, both of you. Thank you again for the article in the conversation. I urge people I'll put that on the website, but that's a very, very good article. And gentlemen, thank you so much for being with us today and providing this excellent information, and good luck in the future.
Thank you.
Thank you very much.